Trend is a time series has a lot of different things. The trend means as time goes by. Right? As time goes by, what happened? I know there's a little more fluctuation, but actually this is like moving upward. And then we have a clear the slope. So this is like the regression with the time. So whatever the y value, and then if you do the regression with the time only, then that's the result will be the trend line. So trend is the I don't want to see the small fluctuation here. I mean, when we talk about trend, is the how my data is moving upward or the downward over time. Yeah, of course, not only the time affected here, a lot of different things will work on, but can I just capture the what's going on over time? That's the what we call the trend in the time series data. Modeling is like this again. T is just only the variable, independent variable, and then you just find out. Then you will see the what is the intercept and what is the slope of the line, and you can see the um, your data is keep going up or keep going down, so you can find out the linear line over the time. What if we have a like an exponential time trend? So actually this is the exponential time trend. This is moving this way, right? So instead of the having a exponential here, you can use a log here, or you can do this is like e to the alpha 0 plus alpha 1t. But basically this is the same thing, so you can have a apply the log to the y, and you can get a same exponential time trend. Right? So this small fluctuation will be a result of certain other factors, but I want to see only the what's going on over time. So how can I use the trend line in the regression analysis? So you can actually taking out the trend factor, and then you can because the trend sometimes this trend is too big, so you cannot see the effect of the other factors. So sometimes we taking out the trend to see the other factors effect. So that's what we call this a D trend. So this is the case is the per capita house investment. Yeah, doesn't matter if it's a log or not, but we want to know the per capita house investment, and then house price index. So this is a positive. It looks like investment and price has a positive relationship. If you have a high price and we have a high investment, but actually, if you include the time, right, the investment has a negative relationship with the price. Okay, this number is a standard error. So actually, if you take a look at it, our coefficient is the smaller than the standard error. So this is a no significant relationship because the error is way bigger than the number itself. So we cannot say this is significant, right? However, this one is a 98 versus a 35. So if you this is a more than the twice of this number, so we can say there is the effect. So I don't know the p-value. You have to run the regression to see, but I think this one will have a high p-value, and then this one will have a low p-value here. So that's why it said there's no significant relationship between price and the investment. So what you can tell is according to the previous regression result, right? It's a 1.2 is way bigger than 0.38, so it's a positive. What you can tell is the price index goes up as time goes by, right? Price and time will have a positive relationship. That's why when we take out the time, it looks like the price goes up, per capita house investment is going up, but actually investment is going up as time goes by, not the effect of the price. So when should we include the trend is you have to find out there's a obvious the trending behavior is moving up or moving down significantly, okay, or your dependent variable or some independent variable, right, clearly has a trend, then you have to do it. You have to add the trend. Of course, trend is for the because this is about the time series data. So sometimes we take it out the trend effect. Trend has been subtracted. Then we can see some effect on the dependent variable may only be visible. So that's why we want to find out the trend and then taking out the trend, and then we will see the other factors effect on our dependent variable. So that's what we call is a detrending. It's like a detrending. But if you calculate it, actually, since we consider everything is like the linear combination, so coefficient in regression, including trend, are same as a coefficient in regression without trend, right? However, we can see the more clearly what is the effect of the other factor only when we can take it out the trend effect. And the R square also, sometimes the trend is too obvious, and then trend, because of the trend, we can have a pretty high R square. That's possible. So when we run any different kind of the model, all of them can have a pretty high R square. That's why due to the trend, the variance of the independent variable will be overstated. So we can have a pretty high R square. So it's better to detrend first, and then run regression, and then we can find out which one. So like a model selection, if the trend is pretty high, you're gonna have a pretty difficult time to find out adding this one really increase R square or not, because R square is dominated by the trend. So adding another the predictor or not may not show up as a strong difference. In that case, we better do the first detrend, and then run the regression and then find out what is actually some independent variable is pretty good for the predicting our dependent variable or not. Seasonality. Seasonality is the something is repeating over a year. This is the within a year. So seasonality is not only about the like a spring, summer, fall, winter, even though that's a season, but it can be like every month things, right? Or even though it just happen only once per year, so like demand for the spooky mask is only has a high demand in October because of the Halloween, right? So Christmas item is only have a high demand in the December. So it happened only once, but that's repeating. And then same time of that year. I don't care if it has like a this kind of curve or it has a like only one peak here, but this will repeating every year, same time of the year. Okay, that's all of that kind of effect we call is the seasonality. So some simple method is including the set of seasonal dummy, but seasonal dummies depends on the what you are trying to use. This is case is a February, March, April, and December. Um, that's the like a monthly. So every month you have some kind of the thing is changing. So for example, it's like a March we have a pretty high demand, but every year it's different. But March is always has the number one demand month. Then we will give the high positive coefficient on the March, and then that repeating every year within a year. Then that's what we call is the seasonal effect. So regression coefficient on the explanatory variable can be seen as a result of first decentralizing the dependent and explanatory. Decentral seasonalizing also can be here, this one. This alpha 1 or the beta 1 or beta 2 is the if we taking out the seasonal effect, right? This is a deseasonalized dependent and explanatory variable, right? So this coefficient, this is a regression coefficient on the explanatory variable can be seen as a result of first decentralizing. If we taking out the seasonal effect, taking out, then this is the coefficient. But if we just get rid of this, then you may have a different value here. So R squared that is based on the first decentralizing the dependent variable maybe better reflect the explanatory power of the, so this is a dependent variable. So same thing, when seasonality is very strong, then you cannot see the R square is dominated by, again, just like a trend, dominated by the seasonality, then you cannot see the real effect of the adding x2 or not, x3 or not, you cannot tell. So when you trying to select the model selection, the select the independent variable, maybe you better take it out the you don't have to actually divide anything, so you can just include this dummy variable and taking out the seasonal effect, and then you can calculate the R square. That might be the better or easier way to find out which one is which explanatory variable has a better prediction power or not. So this should be the our last video, and then since we have a trend and seasonality, the next class will be about the forecasting.